Solar energy. What is solar energy? Solar energy is energy that is derived from the sun in the form of solar radiation, which makes production of solar electricity possible. Solar energy is the cleanest and most abundant renewable energy source. In 2019, only 1% of the world's global energy came from solar technologies. However, an analysis by Bloomberg Energy Finance says that about 80% to 100% of the world's energy in 2015 will be sourced from solar and wind energy. History of solar energy. People have used solar power as far back in history as the 7th century BC in its most primitive state. The earliest uses of solar power include focusing the sun's energy through a magnifying glass to start fires for cooking. However, the first photovoltaic cell was invented in 1954 by a French scientist, Edmond Becquerel, who determined light could increase electricity generation. In 1954, the first photovoltaic cell was invented. In 1958, solar energy was used first in space to power satellites. In 1981, the first solar power airplane was built. Uses of solar energy. There are various uses of solar energy, such as generating electrical energy, heating water, space heating, solar cooking, charging portable devices, remote communications. The Princess Elizabeth is a base in Antarctica that runs entirely on renewable energy sources such as solar and wind, since they're available in abundance and extremely cost effective. If they can do it in Antarctica, we can most certainly implement it globally. There are certain advantages of solar energy as well. Solar energy reduces greenhouse gases, solar energy is cost effective, and uses an infinite resource that is the sun. Solar energy in the United States. 2% of America's electricity is generated by solar energy. Most solar power generation in America is done through photovoltaic cells and partly from solar thermal energy. The state of California produces the highest amount of electricity that is produced from solar energy, contributing to 37.6% of the US total, followed by Texas at 7.5% of the US total, North Carolina at 6.9%, Arizona at 6.2%, and Florida at 5.2%. Fun fact: tech giant Apple is now the leading procurer of corporate solar energy in the United States, with nearly 400 megawatts of total installed capacity. Apple announced last year that all of its operations are now 100% powered by renewable energy.
Addressing the question, is solar energy a viable source of energy for Wisconsin? The answer is yes. This bar graph shows that installations soared in 2017 in Wisconsin. On the bottom, the blue represents residential and yellow represents businesses. And that light blue represents utility. Projections for the next 10 years forecast more residential installations, and you can see that is true when you look at 2018, 19, and 2020. Lower costs and increased efficiency are factors which have led to the growth of solar energy in Wisconsin. Another piece of proof that Wisconsin has a viable means of solar energy production is this. This shows Wisconsin's sources of renewable energy, which include hydro, wind, biomass, biogas, and solar. The straight line along the bottom, in that brown color, represents solar. Solar has remained linear from 2005 to 2017. And we saw in Figure 1 the enormous spike in solar installations in 2017. And if this graph continued, the linear line would show exponential growth in 2017 and beyond. Solar energy is a small piece of this Wisconsin 2017 circle graph. Using the Wisconsin Energy Information Administration's statistics, in 2019, 8% of Wisconsin's generation of energy came from renewable sources. Production of electricity is changing to cleaner, healthier ways in Wisconsin. These changes will increase the slice of the circle for solar over the next 10 years. And while this isn't 2017 or 2019, you can see that renewable energy is on the rise in the state of Wisconsin. A huge pro of solar energy is how it helps significantly reduce our dependence on non-renewable resources. Currently, 85% of the world's energy is from non-renewable sources, which will be used up in the next 30 years. This is why solar energy is emerging, because it requires only panels and sunlight. This allows for the reduction of harmful emissions such as carbon dioxide and other pollutants into our atmosphere, which come from burning other fossil fuels. Solar is healthier for humans and wildlife as it's the cleanest source of energy. Solar energy is also inexpensive to maintain, and costs of panel installations have decreased by 75% in the past 10 years. This allows families a viable choice regarding solar energy. After installations, energy costs in Wisconsin are 3% more effective than the rest of the nation. People worry solar farms will be noisy, smelly, and cause issues with air quality. Fortunately, the opposite is true. Solar farms are good neighbors, clean and quiet. There are no chemicals or pollution coming from them, and they do not tap into the local water supplies in order to run. They're able to power large companies, businesses, and entire neighborhoods effectively. In general, the few cons of solar energy have workable solutions. For example, people claim solar is negative since it cannot work well on cloudy days or at night. While true, the technology has advanced with a battery that helps to harness solar energy during the day, which can be used at night to provide a home with energy. This diagram shows all the moving parts. It's expensive and a large cost on top of panels to get everything you need to have an efficient solar energy machine. And experts claim that batteries now need a larger capacity. When these batteries need to be discarded, there will be environmental impacts. Another con of residential installation is having adequate roof space for panels to be installed. Location of large solar farms can be detrimental to land use, as well as animal habitats and wildlife. Solar farms were originally designed to be in the desert, so valuable farmland wouldn't be used by a gigantic solar panel. Putting them in other locations, which is what has happened, makes land unable to be used for anything else and displaces wildlife. Ironically, solar panels create cleaner air, but the process to produce the components of them involves toxic chemicals which are a danger to humans. The manufacturing process also causes global warming emissions. The materials and manufacturing are the most severe of the cons and need scientific advancements to become safer.
There are two ways to harvest solar energy: passive and active collection. Active solar collection converts the sun's energy into a usable form, such as electricity. Passive solar collection uses the heat of the sun to heat living spaces. If you've ever gotten into a parked car on a sunny day or gone to a greenhouse, those are two great examples of passive solar collection at work. On the top here, you'll see a house that's using passive solar collection. The large windows and overhanging roof help block the sun out in the summer months, but allows for the heat of the sun to stay in during the winter. On the bottom, we have an example of a house utilizing active solar collection through solar panels, which I will touch base on those in a bit. Since passive solar collection involves no working parts, it makes it a simple and cost-effective solution to replace the need for gas and electricity. However, the results may vary depending on the climate or weather. In a climate without a lot of sunlight during the winter, it may be harder to get enough sunlight needed to effectively heat the home. And then on the flip side, if it is particularly hot and sunny environment, the home may end up overheating. As you can see here in the image, the house has an overhanging roof here that lets the winter sun in, but then blocks out the summer sun. It also has a thermal mass floor, such as concrete, which absorbs the heat from the sun during the winter, and then it also absorbs any remaining heat in the house during the summer. Contrasting to passive solar collection, active uses mechanical parts in order to harness energy from the sun, such as solar water heaters, solar panels, and concentrated solar power. The most commonly seen on homes are solar panels. Because they do require installation and maintenance, though minimal, it can be more costly than passive solar collection. One huge benefit, though, is it can be added to a pre-existing house and doesn't have to be specially designed like passive solar homes do. Speaking of solar panels are able to generate electricity by using the photovoltaic effect. The photovoltaic effect is simply described as light is absorbed to produce an electrical charge. The solar panel is able to separate charges through a built-in electrical field. That process generates voltage or an electrical charge. Solar panels are typically comprised from silicon. Silicon is a semiconductor, meaning that it is partially conducting current. There are two types of silicon used in a solar panel, a p-type and an n-type. The n-type has more electrons that are able to move, making it more conductive than the p layer. The p layer, however, has less electrons that are able to move. Where these two layers meet, which is right here in the yellow, is called the p-n junction, or the depletion region. Electrons are able to cross the junction, thus creating a positive charge on one side and a negative charge on the other. The atoms in the silicon are connected by 4 bonds that keep the electrons in place, meaning that no current is able to flow through. Light rays are made up of photons. When a photon comes in contact with a silicon with enough force, an electron is knocked from its bond and leaves a hole. The loose electron is drawn to the n side, and the hole is drawn to the p side. Mobile electrons are collected through metal strips on top of the cell. They flow through an external circuit and perform electrical work such as powering a home, business, or powering a light bulb. Like you can see in the picture above, the arrows are signaling the electron flow. So they come up through these fingers and then flow here, and then they flow back. The electrons are then returned by a conductive sheet of aluminum, which is shown right down here, and returned to their original positions. In the photovoltaic effect, the electrons are the only mobile part. So the electrons are the only thing moving around in this entire system. Each individual solar cell is only able to put out half of a volt. The more solar panels that are strung together, the more power that is able to be generated. Because electrons are the only moving part in the solar panels, there is less to maintain and less that is able to break down or degrade, thus giving the solar panels longevity.
Hi, my name is Jin. I'm going to talk about case study for solar energy. And the solar energy case I chose Jeff and Cindy hybrid system. I made 3 questions I want to answer later on. The next topic is I'm going to talk about his big concern about electricity. So most of his concern by using amount of electricity was highly charged electric bill and his carbon footprint. He became one of the customer in Power Home whose residents count prospering Indians, who step forward to help the environment with reduced electric bill. An in-person motivation to accompany with their customers was when he has perception of he was using in terms of the Earth's resource until recently. He found that grid electricity primarily generated by fossil fuels such as natural gas core had emitted 1,000 tons of carbon dioxide into the air annually and added up to massive carbon footprint for all. In turn, he saw how the solar panels could reduce that. And next, what he got benefit. What he got benefit from the solar panels. As you see here, he set up 17 panels array on the roof, like this. And then, like the result was so amazing. Like his new 14 electric bill down 90% from the 140 bill he got from the month prior to adding solar. So he got 14 but down $14 bills by solar energy, solar panels, while he opted for an offset of like approximately 67% of electric bills. And there were a few reasons why he saw additional savings. First of all, when he had gone for 2 weeks after their solar panels were energized and being away, they turned off their air conditioner to keep from wasting energy. They returned to find that his home had only used 20 kilowatt per hour during their absence, so with electricity price of like 12 kilowatt. However, his home used only like $2.4 of grid energy during that fortnight. And he knew that there was better environmental legacy. He contributed better environmental legacy. The next one is the effect of solar panels globally. So as you know, the greenhouse effect is the way the heat is captured to the surface of Earth by greenhouse gases. So, and then one of the greenhouse gases filled with like hydrogen, carbon dioxide, no, water and carbon dioxide, methane. So as you know, carbon dioxide consists a lot of portion of the greenhouse gases. So if we burn more fossil fuels, then more methane comes up and combines with oxygen. Then they make some product like carbon, water, and heat. So if we burn or if we use more fossil fuels to to generate electricity, then greenhouse gases filled with carbon dioxide, more methane, so more heat is captured by, let's say, reflected light. So more heat is captured. That means the Earth gets hotter than now, and it could cause climate change. That's why we need solar panels to reduce the climate change for now. Next one is measure data. The measure data, I made a measure data with a 3 case study to know how much electricity we can save by solar panels. So as you see here, first the case study represent Jeff and the Cindy Harvard system. So as you see here, 99.3 of carbon emission had removed from solar panels, and only 0.2 pounds used by electricity. So the like 0.2 pounds of carbon emission was emitted. So the amount of reduced CO2 emission is equivalent of car like carbon emission approximately like 27.4 like 27.7 pounds per day. And the reduced amount of carbon will contribute the Earth to mitigate the climate change, because one of the main reasons which will spread like greenhouse gases like caused by carbon dioxide when you burn more fossil fuels. So definitely will be lower impacted by solar panels.